look like something happened. It's like my stream crash. Is that what happened? It did. Something like. Okay. That sucks. That sucks that my stream crashed. But whatever. Looks like, I don't know. I've been having like Wi-Fi problems for a while. Is this even okay? Any problems, then I guess I should stop. Probably okay. Uh, Alright, whatever. Yeah, it's over. I took a minesweeper break in the bathroom, so bad. Okay. From equation 15.5, we see that as the sine and cosine functions oscillate between plus minus 1, the extreme values of velocity are plus minus WA omega A. Likewise, equation 15.6 shows that the extreme values of acceleration are plus minus omega squared A. Therefore, the maximum value of the magnitudes of velocity and acceleration are. So now they're telling us the velocity max equals WA equals KOMA, and acceleration max equals squared A equals K over MA. Okay, so there's the formula. I don't really know how they found that, to be honest. And A is amplitude, right? Okay. Oh, so X equals capital A because the amount you pull it back is the amplitude. Okay. Figure 15.5A plots position versus time for an arbitrary value. They show that velocity differs from a phase of the position by pi over 2 rad, or 90 degrees. That is when x is a maximum or a minimum, velocity is 0. Likewise, when x is 0, the speed is a maximum. Furthermore, notice that the phase of the acceleration differs from the phase of the position by pi radians, or 180 degrees. For example, when x is a maximum, A has a maximum magnitude in the opposite direction. An object is mass m is hung from a spring and set into oscillation. The period of the oscillation is measured and recorded as t. What does this say? I don't know. Can't even. Mass m is removed and replaced with an object of mass 2m. When this object is set into oscillation, what is the period of the motion? If you look at the period formula, it doesn't even look like. Oh. Hold on. Since period equals 2 pi over omega, and omega equals root k over m, that means that omega. Oh crap! I have to make like a clean space for my formulas. I have to separate everything up. So that would mean t equals 2 pi over w, which is 2 pi divided by k over m. k over m, which is multiplied by root. But that's not how it works. You can't like separate them. Fuck. Let's say k is 1 and m is 1. It would be 1 root. It would be like 2 pi. But if k was 2, it would be 1 over 2 root, which is 1 over 4. God, I'm stupid. 2 pi multiplied by 1 over k over m rooted, which is what t is equal to. Here, I guess I can show you guys, or I guess it's relevant to show you guys. Okay, pay attention up here. 2 t equals 2 pi divided by k over m, which I got from the formula here. T equals 2 pi over w, and w equals root k over m. So now I took the formula, and when you divide something, you invert it, right? So now it's 2 pi divided by 1 over k over m, root. Let's say that k is 1 and m is 1, which is like you can just make up numbers. It's okay, you're allowed. Then t would equal 1 over 1 over 1 root 1. So it's just 1 over 1, which is just 1. So t would equal 2 pi in this scenario. Now they're asking that if you double the mass, what would happen? So now let's say that m is now 2 and k is 1. Now it would be 1 over 2 rooted. So 0.5 rooted is what? Actually, I gotta pull out a calculator. I have a calculator right here. 1 over 2. Oh, my calculator is all dusty because I haven't used it in a long time. It would be 1 over 2, or it would be 1 over... What is this? This is weird. Hold on. I'm stupid. 1 over 2 rooted. 0.5 root. So it would be 2 pi times 1 over... 0.5 root is the same as like root 2 over 2, isn't it? Root 2 over 2. So root 2 over 2, let's say, and then you invert it, which is 2 over root 2. 2 pi multiplied by root 2 over 2 over 1 like this. You're gonna have to like... Holy crap, this is a lot of fucking... This is really annoying. Multiply both by root 2. You know how you multiply things by the conjugate? Now you have 4 pi root 2 over fucking 2. Now you take this and you have 2 pi root 2. So it means that you just multiplied it by root 2. Or you just multiplied it by root 2, which is just t times root 2, I think. So if you go and you look at it, it's b. It's b. I think it's b. 15.4. It's b. God. I might be cooked. It's okay. It's the start of the fucking school year. There was probably an easier way to figure that out. Okay, now equation 15.6 describes simple harmonic motion of a particle in general. Let's now see. Suppose the particle is set into motion by pulling it from equilibrium by a distance a and releasing it from rest at t equals 0 in active figure. To obey the initial conditions, x0 equals a and v0 equals 0. X as 0 equals a cos phi equals a. V as 0. Okay, so now, once again, I'm just gonna write the formula down, but like I don't know what's going on. X is 0 equals a cosine phi equals a. V at 0 equals negative w a sine phi equals 0. God, I hate physics. Serious business. Conditions are met if phi is equal to 0, which is like the phase shift. Giving x equals a cos omega t as our solution. Take a break and plus 6 left. And I'm supposed to stream for 18 hours. So that means that I did 2 hours, so that's 16. I have to do like 8 hours in today and tomorrow. Like if I wanted to make my quota, which is like I probably will not. Or I can't imagine that I would. Can't imagine that I can't. You know, I have Wednesday off, so if I divided it by 3, 16. So 15 is still like 5 hours per day. You know what? That's what I deserve. That's what you deserve if you choose engineering. If you don't want to do that, then pick business or something. Furthermore, the velocity has extreme values of omega a, which both occur at x equals 0. Hence, the quantitative solution agrees with our qualitative description of the system. Let's consider another possibility. Suppose the system is oscillating and we define t equals 0 as the instant the particle passes through the unstretched positions of spring while moving to the right. Oh crap, I think this might be illegal. Whatever. Probably. Suppose the system is oscillating and we define t equals 0 as the instant the particle passes through the unstretched position of the spring while moving to the right. Active figure 15.8. In this case, our solutions for xt and vt must obey the initial conditions at x0 equals 0 and v0 equals v initial. x0, didn't we do this formula up here? A cos 0, okay, then are they even explaining? If we look here, position versus time, velocity versus time, and acceleration versus time. So this means when this happens, this means velocity was not 0 when I read it probably. Velocity is 90 degrees out of phase with the position, and the acceleration is 180 degrees out of phase with the position. If I knew what differentiation looked like if you take the derivative here, like you're supposed to know. Like this is cosine. This is a sine maybe. This is sine, this is a cosine. This is like a random one. That's why it's important to know trigonometry. Active figure 15.6, a block spring that begins its motion the block at x equals amplitude at t equals 0. In this case, phi equals 0, therefore x equals a cosine omega t. What does this mean? So you have to read it here. First of these conditions tell us that phi must be positive. We have phi equals pi over 2, negative pi over 2. Hence the solution is vi for w equals wt over negative pi over 2. The graphs of position, velocity, and acceleration versus time for this choice of t equals 0 are shown in figure 15.7. Notice how these curves are the same as those in figure 15.7. 15.7b and 15.7a. It's here. Phase constant is shifted by pi over -2 worth of a full cycle. Okay, so let's look here. Here's x velocity acceleration. So this point would be here. So that's why I shifted 90 degrees. This one supposed to be here, it shifted here. So they moved it 90 degrees. This one here, where does the top part go? The top part went here, t over 2. This part went over here. Okay, but what does this mean and why do I care? No, let me drink my tea. I have artichoke tea today. Good. Okay, sorry. I went to take a drink of tea. Okay. The answer, or there's a question here. A 200-gram block connected to a light spring, which the force constant is 5.0 newtons per meter, is free to oscillate on a horizontal frictionless surface. The block is displaced 5 centimeters from equilibrium and released stress. An active figure 15.6. That'd be it. You push the spring, boing boing. That's how it works. The solution is down there. So first, why don't we like take a second and think? Here, I'm gonna draw the problem. See. 200 grams, you should convert stuff like that to kilograms. So mass equals 0.2 kilograms. Force constant is also known as K, so 5.00 newtons per meter. Free to oscillate on a horizontal frictionless surface. The block is displaced 5 centimeters. Amplitude equals 5 centimeters. And is released from rest. Now they're asking what is the period of motion. They're asking T equals, huh? So basically, crap, my pencil. Okay. Answer. Don't show the answer. Fuck. Guys are answer. So now, here's what we're gonna do. 5, this, and this. Now we're gonna look at our formula. And this is probably the one we want, right? Probably. Xt equals a cosine plus phase shift, which is 0. But we don't know how much time. So let me just sit for a while. Oh, what about this formula? T equals 2 pi over omega. And omega equals k over m. There. This is the solution. So T equals 2 pi over k over m root. Okay? So we're gonna fill it in. T equals 2 pi, this period, right? And k is 5 newtons per meter over 0.2 rooted. So 5 over 0.2 rooted. T equals 2 pi over 5. Is this the answer? I don't know. That's supposed to be the period, but that's not even right because that's not even seconds. So hold on. How could this be period? Oh, well, this m over k, k over m. Oh, so you can do that like in the thing. Okay, so obviously that's wrong because period is supposed to be in seconds. I think for a second. We don't have the time, so we don't know. Is T supposed to be period over here? Okay. Okay, well, I've been thinking about it for a little bit, but it looks like I'm too stupid. That's pretty depressing. Okay. If you guys are okay, I'm gonna go look at the answer now. Ready? Conceptualize. Study 15.16 and 15.6 and imagine a block moving back and forth. Block is moving modeled as a simple harmonic motion. Find values from developed in this section for a particle in simple harmonic motion model. So we categorize this as a substitute problem. Rad per second. Oh, I didn't think about that, but you can do like 2 over 5? That's not how it works. What the fuck are rads? 2 times 3.14 divided by 5. Nope. Divided by 2. Nope. Am I stupid? Or something? Answer that question. Okay. 2 times 3.14 divided by like 5. How do you even get rads? By 5. I don't even understand this question. Like I got the answer. Like basically I got the answer, which is 2 pi over 5, but like I don't know how to convert into rads. And determine the maximum speed of the block. Okay. Can I just like have a second? I've been taking a lot of seconds to myself recently. This thing on. Oh, suddenly my fucking Pomodoro timer doesn't activate. Okay. Okay, now we're gonna determine the maximum speed of the block, okay? So, now we're gonna go back to my thing. And if you guys remember, we have a formula for the maximum speed. Right here. WA equals K over MA. A is amplitude. Or Vmax does Vmax just equal WA? And we have the amplitude, which is just 5 centimeters, right? So, or we can just do this. Well, 5 centimeters, you have to divide it by 100. So WA amplitude is K over M root. K over M is 5 newtons per meter over M, which is 0.2 kilograms rooted, multiplied by A, which is 0.05 meters. 5 centimeters. This was 50 centimeters, so that's 5 centimeters. Okay, let's try it. 5 divided by 0.2 rooted times 0.05. So if you do this, then it should be 0.25 meters per second. You guys ready? You guys ready to look at the answer? Okay, I was wrong. Oh shit, I keep fucking looking at the ready thing. Oh, I was right actually. I'm a genius. Oh my god. Oh my god, I got it right. Oh my god, I got the easiest question right in the textbook. Let's see, what is the maximum acceleration of the block? Okay, let's go look at that. A max equals W squared over A, which is K over MA. So we can just copy this one, except it's 0.5 over 2 and no root. So 0.5 over, or 5 over 0.2, no root, times 0.05. So velocity equals this, I guess. Well, you guys can fucking imagine it. You just take the root off of the thing that I put. Now you get 1.25 meters per second squared. Hold on, I'm trying to get like the units right because it doesn't look like I can figure out the units. Newtons per meter is kilogram over second over m. So it just like gets rid of the kilograms because it's kilograms over kilograms. Okay, anyway. Yep, and there it is. It's 1.25 seconds. Express the position, velocity, and acceleration as functions of time. I have no idea what this means. Okay, you know, we should get used to being stuck. However, our break is in 1 minute, so I just take a break, and this is only 15.2 as well. Like, we're not even close. I was hoping to complete the chapter like today. We still have like, well, I think we're about to wrap up 15.2, but we still have to do 15.3. Okay, yeah. I did 2 sections in 1 hour, so I can do 2 sections in another hour probably. And then, well, I don't know. Like I said, every time I go like I'm gonna take a short break, I do not come back to stream. I go like, oh, I'm gonna go stream, and then I don't come back. So obviously, I just gotta like pull myself together. But anyway, let's take 5 minutes off. Okay, so what should I talk about? There was this guy who I just moved. No, that wouldn't be good. I don't know. I was in my class and I was sitting beside this guy and like he really like pissed me off even though he didn't do anything, you know? You ever met like a person who just like rubs you the wrong way? Like he wasn't even, you know what he was doing wrong? He number one, he like didn't respect my sitting space. He sat like really close to me, like way too close. And he was like invading my like seating area, which is like made me mad. Number two. Number three, this guy like started like eating in the class, and then I was thinking back to like when I ate in my class, and it's like, you know, I used to bring my sandwich, my lunch, and I used to think it was like more efficient to eat my lunch like during class. Number two, I don't know. That's just like, so it's like when he did it, I was like, oh my god, that's so terrible. I'll never do that. But like I did it. So it's like, you know, I gotta like have the self-awareness to understand, you know. And like he was like eating quietly too. So like honestly, like he didn't do anything wrong. So I don't know why like I just like, you know, I don't know. Am I evil? Am I evil for like thinking that? Because it's like some people you just like instantly know, you know, you're gonna hate, but it's not like is that like some kind of like fourth or sixth sense? Or is it just because like, you know, your like impression on them, you like predetermine your impressions on them and then you just like immediately if they don't do something or if they do something wrong, you just like, oh my god, I hate them so much. Right, so I think that's pretty terrible, you know. I think you know, I was watching Northern Lion. Shout out to small streamer Northern Lion. And he was talking about that and it was like, oh, it wasn't like an eye-opening moment for me. He was talking about like the airport thing. That's like, you know, it's like you're not always like the I'm gonna be good, but like usually I do try to be like, you know, honestly, and I think it's honestly been like pretty bad for me because I don't sit near people. It's like I try to like get away from them because like if you sit right beside them, like what are they gonna think? They're gonna think you're like a weirdo who wants to be their friend, right? But like I don't really want to make friends. I guess I'm like a Araragi from Monogatari before his character arc. I don't need friends because they make me weaker. Which, like, you know, obviously when he gets to his character arc, it's like, that's not true, right? I need friends because they make me strong. Or, like, it's okay to have friends. That's what he accepts. But, you know, I'm like a character. I haven't reached my character arc yet, I guess. I mean, like, Araragi got it in, like, he, like, made his way in at college, first year of college. But also, he was, like, molesting little girls, so you know, it's like you take the good with the bad, right? Or something like that. You know what? Whatever, bro. I wasn't doing that. I wasn't doing that stuff. If that. Yeah, that was a pretty terrible day. I was supposed to go to the gym yesterday, but I got so like like that whole thing like ruined my day. So I just like went home immediately, and then I played video games until I went to sleep. And obviously, I was supposed to stream yesterday too. Like I just feel so tired, man. I don't know. I like get home. I got home at like 1 o'clock or 2 o'clock, and then I had to eat my lunch. It was like 3 o'clock. But the reality is, I just spent all of it playing video games. And then I have to like walk my dog at like 5 o'clock, right? And it's just like, oh my god, it's like, why would I stream? But like 2 hours is plenty of time. Like I have to like kind of like get myself together. But it's like I'm so messed up. I'm like, oh my god, like I have to walk my dog today, so I need. Oh my god, my nose is so stuffy too. I'm getting sick. I'm like, oh my god, I need a break. Actually, let me use this from the last moment of my break to like clear my nose. All right. All right, my nose is like a little more clear now. Okay, so breaks over. Express the position, velocity, and acceleration as functions of time. I don't know what this means. Does this mean that like xt? Okay. Express the position, velocity, and acceleration as functions of time. What does this mean? What could this mean? And I should just back up, put it down because I didn't want to like I don't know. I can't tell you. Position, velocity, and acceleration as functions of time. So I have the formulas here, but like how do I express it as a function of time? Okay. Yeah, can I just give up? Give up on this question? Let's go down. Find the phase constant from the initial condition that x0 equals a cos equals a phi equals 0. A x equals amplitude at t equals 0. Oh, I think I understand. So, no, I don't understand. Okay. Use equation. Okay, whoops. use equation to write. So we just got the position, and then they're asking you to do like cosine 5t and phi is 0. And you know that omega is 5 because we already established that. Oh, and you found that socks are like getting all wet. Like, I don't know why, but my feet are like sweating. That like happens a lot. I gotta take off my socks. Alright, that's really nasty. Okay, I almost understand it, but I need to look at it for a little longer. Velocity equals omega a, negative omega a sine omega t plus phi. Phi is 0. T is also. Oh, they put t as like just t. They left t. And they want you to make a formula that allows you to solve it using the variable t. Or something like that. Okay, hold on. Can't even think about this. Omega, which is 5, times amplitude, which is 5 centimeters, right? So 5 times 0.05. Oh, so that's, I think I almost understand. Okay. What if? What if the blocks were released from the initial position xi 5 centimeters, but with an initial velocity of vi equals negative 1.1 meter per second? What part of the solution changed? And what are the new answers for those that do change? Okay, so I don't know. You would have to divide the initial velocity by negative 0.01. So it would be like the whole thing is being divided by negative 0.01. So it would be 2.5 or 0.25 negative divided by 0.1 negative. Is like, I guess I can show you like if I like put it here per 2.5. 2.5, it would be 2.5 meters per second sine 5t, which is like what I think, and the other two would not change. Let's look. Part A does not change. Okay, fucking okay. They should ask you. They should have told me like whatever. Now we're just looking at all the answers. Lie down. Tired. I'm fatigued and I want to complain. Complain. Okay. Sorry. Okay. Sorry. Oh my god. That was kind of gross. WA sine phi a cosine phi. My god. Tan phi equals negative velocity initial. You do the RADS calculation. Okay, but they really want you to like do everything. Want you to do like this particular what if is easier to solve from energy approach. I'm gonna tackle that in the next section. Watch out for potholes. Car for mass with a mass of 1,300 kilograms is constructed. So its frame is supported by 4 springs. Each spring has a force constant of 20,000 newtons. 2 people riding in the car have a combined mass of 160 kilograms. Find the frequency of vibration if the car after it's driven over a pothole in the road. Frequency is F. It's not angular frequency, so F can equal 1 over 2 pi k over m. 1 over 2 pi k over m root T equals F equals. Fuck. Okay, pay attention. I got this formula F from here. This one that we wrote down. Remember? Okay, so now let's try doing it. 1 over 2 pi. 13, the mass of the car is 1,300 kilograms. The car has a constant, I did it wrong. The car has a constant 20,000. 20,000 newtons. 20, 1, 2, 3, 4. Is that? Yep. Over 1,300. I think they'll watch out for potholes. So obviously it's a double. I think it's a double entendre because it's like, you have to think of it, it's like a trick question. But the 2 people have combined mass of 160 kilograms, so it would be 1,300 plus 160. You have to include the people. 460. Or maybe the trick question is that the people like don't matter. But anyway, you can calculate it, right? 20, 1, 2, 3 divided by 1460 equals 13.69 rooted. You have to root it. 3.7 now divided by 2 pi. 3.70 over 2 pi, which is like radians, divided by 6.28, then 0.589. Then I think if you have to change, you have to do like times 1. Okay, no. It's like 0.589 rads. I don't know. Or this is seconds actually. Fuck. Here. Okay, you guys see it? Whatever. That's my final answer. 0.589 seconds. Now let's go look. Think about your experience with automobiles. You push down the front bumper, the car oscillates a few times. So maybe it's like there's a period shift or there's a phase shift. An expression. Okay, so look, I already got it wrong because there were 4 springs, so they added it. Okay, so why don't I try change my answer? 81, 1, 2, 3 divided by 1460 root times divided by 1.17 rad per second. 1.178, which rounds to 1.8 hertz. Okay, so obviously I got the question wrong. So, obviously it was a double entendre. Very funny. Very funny, Sir Wajo Wet Physics Textbook Edition 7. That's really funny. Fuck you. Frick you. Okay. Finally, sorry, I'm making a lot of mouth noises. I'm having like trouble breathing now. Sorry. Okay. Mass we used here. Crap. God damn it. There's a grime on my. I have to clean it off. I was supposed to clean it off like 2 days ago. Okay, so don't forget, if there is more than 1 spring, basically what they're trying to tell you is that what they're trying to tell you is that if there's more than one spring, you have to add the hertz together, or the spring constant, the force it can take. Suppose the car stops on the side and two of them exits the car. Yeah, the mass is smaller, so the people get out of the car. Obviously, it's like that. So I got that question wrong. Oh my god, I'm going crazy from this like stuffy nose. But I got the question wrong. That's just how it is in life. Sometimes you just get cooked. What the fuck did I do? Hold on. Zoom in. I got zoom out. Fuck. Zoom out. Zoom in. Probably good enough. All my shit got moved around. Fuck you. Frick you. Oh yeah. Oh my god, and now you want to do it again. What is wrong with you? 15.3. Okay, I don't know why my fucking PDF is misbehaving. 15.3, energy of the simple harmonic oscillator. So now we're gonna have to learn more fucking formula, which is like awesome. Awesome. Not awesome. Okay, let's just do this. It's like, here's formulas for 15.2. And now we're gonna write formulas for 15.3 over here. And then at the end of this stream, we're gonna like review what I learned. Hold on, I gotta like go back. I gotta like check this. Okay, all my stuff got like messed up. I don't know what happened. Okay, hopefully it's like the thing doesn't crash again. Okay, let's examine the mechanical energy. You can assume that the kinetic energy on the block is K. So K stands for energy kinetic, equals half mass times velocity squared equals half mass times omega squared amplitude squared sine squared omega t plus phase shift. The elastic potential energy stored in the for any elongation. So this is like K is like when you kick a soccer ball or you like kick a car and it starts moving. You have like the strength of the Hulk. It like starts moving and that's how much energy it has. The elastic potential energy is like when you pull back an elastic band, the energy increases. And it's like the elastic energy, potential energy comes converted into kinetic energy like when you let it go. At the moment it like becomes as fast. At the moment it starts moving, all the potential energy becomes kinetic energy. Okay. I lie down. I have to eat lunch. Maybe I'll eat lunch at 3 p.m. Sorry, I'm just watching the timer tick down. Second. Right back. Okay, hello. That. Let's go back to work. However, it's gonna end in like 2 minutes now, so I want to. Okay. Okay, so I hope you guys had a lot of time to focus on the whatever. You know, you see it here. You see here's kinetic, here's potential, and then here is the energy total. So like when someone's pulling something back and then they let it go, it's like somewhere in between the time, it's like both of them come together. Pause. So now we know that. Here, I gotta write these down. K equals half m squared equals half m omega squared amplitude squared sine omega t pi q equals half k x squared. Just writing down what I see here. Half k a squared cosine squared omega t plus phi. E equals k plus u equals half k a squared sine squared omega t plus phi plus cos squared omega t plus phi. Alright, break. I'm going to the bathroom. Sorry, I've been taking like too many breaks, but that's how it works, right? At least I'm focusing up phone, except for when I take Minesweeper. Alright, hello. Yep, this thing's on. Okay. Hope that nothing. I don't hope anything. I'm just gonna end in one. I don't have anything to talk about. My friends called me. I told him I was busy streaming, so he left. Actually, how long have we been on this page? Okay. Let's get ready. Yeah, okay, so whatever. We already read this. Half Ka, the total energy of the system, the variations of K and U with the position X of the block. Blah, blah, blah. Study it carefully. Okay, fine. Sorry. Told me to pay attention. Okay, so here it like goes down, up. So like they're saying when potential energy is at its peak, kinetic energy is at its bottom, and then as it like decreases, they have like a relationship with each other. Okay. Finally, you can express the total velocity of the block at an arbitrary position, so I might as well just take this. Velocity equals this plus or minus this, and is also equal to this too. So I'm writing this all on my formula stuff, even though I'm not gonna have it like later, you know, obviously. Duh, on the exam. Mega a squared minus x squared. Multiplied by the root. So these are all equal to each other, right? Only problem is I don't know how they like, you know, I don't know their relationship. I don't understand. Oh, hey, opossums. What's up? Got a cat? Is it like an old one or like a young one? What kind of cat is it? Studying physics today. Don't you have more than one cat though? Like, isn't it hard to take care of them? Well, I guess it's not that hard, but like, I mean, a lot of cats. Okay. Once you have a position, once you check equation 15.22, where is that? It's here. Okay, you may wonder why we are spending so much time studying simple harmonic oscillators. We do so because they are a good model of a wide variety of physical phenomena. For example, call the Leonard-Jones blah 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 blah. Okay, this part's not important. You guys can read it by yourself. Okay, so what they're saying here is when you pull a spring back, it's like it has the most potential energy when you pull it back. And when you let it go, it comes back up, down, you know how a spring works, right? So here, obviously the total energy is going to be at its peak. You pull it back, the potential energy is at its highest. When you let it go, it's here. And then it stops all the way at the bottom at its stopping point. And then it goes up again and down again. That's how spring works. So if you look here, I don't know what this graph means. 0, Any name suggestions? I don't know. Well, I feel like you should think of one. Get the honor of naming your pet. I don't know. Always funny when you give a cat a human name, right? Like John or something. Also nice when you give them like a non-normal, uh, like brick or something, concrete, cheeseburger. You don't want to call your cat that. A lot of cat name. Cat name. Uh, Name your dogs. Name your pets. My dog's name is Chloe. Like it's just like a human name. Like you're supposed to name a dog like Sparky or like Coco, or like Baxter or something like that. Those are dog names. Cat names. Calling him dude. Yeah, dude. Yeah, well, let's call him that then. Dude. Funny. His name. Call him like Spring or something. Springs right now, so I guess that's why I was thinking of it. Spring. Sproing. It could be like the name of question. Okay. The atoms in a molecule not move too far. Group of potential energy versus separation distance. The forces between atoms in a solid can be modeled by light, imagining springs between neighboring atoms. Okay, I don't know what that means. Okay. Question a 0.5 kilogram cart. Can I get rid of this or something? What is page? Couldn't read. No. Getting in the way. A 0.5 kilogram cart connected to a light spring for which the force constant is 20 newtons per meter oscillates on a horizontal frictionless air track. Calculate the total energy of the system and the maximum speed of the cart if the amplitude of the motion is 3 centimeters. Okay. Maybe like here. Okay. Okay, so mass of the cart equals 0.5 kilograms. The force constant, which is K, equals 20 newtons per meter. And the maximum speed of the cart if the amplitude of the motion is 3 centimeters. So amplitude equals 0.03 meters. Okay, so those are the three things we have. And they're asking for the total energy. Crap. Asking for the total energy and the maximum speed of the cart. What color is your cat? Like Garfield or something. They made like a Garfield movie, but I didn't watch it yet. A lot of people on TikTok were complaining that the guy who voiced it didn't put enough effort in or something. So I guess he got canceled or something. Okay, so if we look here, we can check the total energy by converting everything. So it didn't move yet, so we can use the formula for elastic energy. Oh, my handwriting's ugly. Okay, half k x squared, where x is equal to a. Is that right? No, I don't think that's right either. Or we can use the total energy from this formula E. So it's half k amplitude squared. So that would be half 20 And then amplitude is 0.03 squared. Okay, so let's do the math. 0.03. Well, I guess everyone names their cat Garfield. Or like most people. It's like, you know, I want to be like the mainstream audience. Okay, so here it's saying that the energy is 0.009 fucking watts or newtons or whatever. So obviously that's not correct. So hold on, now I gotta think about it. Calculate the total energy of the system and the maximum speed of the cart. Crap. Could it really be 0.09 newtons? That's not even true. That can't be right. But this is the formula for total energy, so a squared 0.03 squared times 20 times 0.5. Okay, whatever. I guess I have to accept it because math is never wrong. Now, if we're gonna calculate the velocity, we have the formula right here. So it's k over m, which is 20 over m, which is 0.5. Amplitude is 0.03 meters squared. Okay, but amplitude minus x, those are like two different things. So actually, or you can use the formula of this. If this is the energy and you convert it all to kinetic energy, since this is the total energy, you should be able to put it into K and then isolate for V. So 0.009, I think energy is watts, I forgot. 0.5, and then here's my V squared. Then if I can't figure this out, then I'm just like stupid. Whatever. Divide by 0.5. Also divided by 0.5 again. So 0.036 rooted. 0.189736 equals velocity. So here's my maximum velocity and here's the energy. Okay. Oops. I guess, you know, whatever. Now we're gonna have to go back here. Put it here and let's look at the answer. Conceptualize. A cart is modeled as a particle in simple harmonic motion. I wish this thing would get out of my way. And then it's 9 times 10 to the power of negative 3. So my answer was correct. Joules. It's not newtons, idiot, dummy. And then here, if you calculate it and you solve for the maximum speed. So basically, I got the answer correct. So go me. You should name your cat Silly Guy 99. Velocity max. Okay, here it is. There, I got it right. So go me. Now B, what is the velocity of the cart when the position is 2 centimeters? So now we have to go all the way here and everything's the same except x is 2 centimeters. So how would that change the thing? I don't know. Is it different from amplitude? Let's go here. If the amplitude of the motion, so the amplitude is still 3 centimeters, but now the position is 2 centimeters. So mass equals 0.5 kilograms. K equals 20 newtons per meter. A equals 0.03 meters, and then now position, which is just x, equals 0.02 meters. Actually, there's a formula right here that calculates the velocity. That uses omega, which is root k over m. Okay, so hold on. Crap, wrong. Oops, go up here. Oops, don't look. Okay, here. Messing up my stuff. Okay, so here's all the formulas we have, and now we're gonna look here, and we're gonna use this formula since velocity is equal to omega amplitude minus x squared, which we have both of, an amplitude. Omega is k over m, or it might be the other way around. I don't remember. Okay, well all I can do is turn the paper around, and omega equals k over m. Okay, so lucky me, root m, and now times amplitude. K over m is 20 over mass is 0.5 rooted multiplied by the root of amplitude, which is 0.03 squared minus 0.02 squared. So okay, it looks like I can get this answer right too, but like I should be like remembering. Okay, so here, so I'll just put my camera here, or I'll just put my calculator here. 0.03 squared minus 0.02 squared, 0.05. Now you have to root it. Root times 20 divided by 0.5 root equals. So now you get the velocity. Velocity equals 0.1414 meters per second. So let's go see if I'm right. I'll put this back here and then go up here. So did I do this right? I did. I got it right. Yippee, 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 yahoo. Okay, so I got it right. So go me. Now I gotta calculate the kinetic and potential energies of the system when the position is 2 centimeters. Gosh, can I take a break? You should name your cat Bolt. Actually, I wish I named my dog. My sister actually named my dog, but like now that I think about it, like I was wondering what I would name my dog. Like what would I have named Chloe? It's a girl. Chloe. Sleeping here. A good name. Like Scruffy. That's actually a boy's name. Like Flower or like Chrysanthemum. There's a book that I read in like kindergarten called Chrysanthemum. Actually, it's not break time, so I can't even talk. Compute the kinetic and potential energy of the system when the position is 2 centimeters. When the position is 2 centimeters, now you have to calculate the kinetic. So since we already have the velocity from here when it's 2 centimeters, so now we can just take the velocity and put it in kinetic and potential energy. So okay, I'm out of space. I ran out of space here, but like K equals half mv, so 0.5, and then v squared is 0.1414 squared. Yep. Turn my light off. 0.1414 squared times 0.5 times 0.5. Okay, so kinetic energy equals 0.00 like 5 joules. And now if we go look at elastic energy, it's probably going to be the same. Actually, it might be a little different. So I'm just using this formula right here. Can you guys see it? Half kx squared, and we know that x squared is 0.02 centimeters. So it is different. Squared times 0.5. 0.2. Okay, I'm trying not to swear. No saying cuss words. Times 20 times 0.5. So K equals here, and then fucking, okay, I just said I was gonna swear, 0.004 joules. So they're basically the same. I don't know. I don't think they're supposed to be different. Or they might be. Okay, now if we go here. Get out of here. Okay, here it is. So now we said K equals 0.5 and U equals 0.4, like 0.004 and 3. So I got it right again. Yippee. Notice that the sum of any potential and kinetic and potential energy is equal to the total energy found in part A. So this is 0.4. So this is 0.005 and this 0.004. They add up to 0.009, which is right here. Because obviously the energy has to add together. Okay, finalize. Notice that the sum of any kinetic and potential energy... oh, I already read that part. Okay. What if? What if the car had been set into motion by releasing the car from rest at x equals 3 centimeters? Oh my god, can the break come soon? I'm really tired. What if the cart were released? This is actually my last break and then the video is gonna end. But then I don't know what I have to do after because I still have to record. I only did 2 hours today and I still have 18. What is it? 18 hours or was it 16 hours? What's my quota? 18. So now I have 16, and now I did 2 again, so now that's like 14, but I still have to do like a ton of hours. God damn it. Gosh darn it. Or I could just take a break. I could take like a 1 hour break. I never come back. Never ever come back. And then if I do come back, I have to like draw another picture. Whatever. Okay. The cart in this example has been set into motion by releasing the cart from rest at x equals 3 centimeters. What if the car was released from the same position but with an initial velocity of negative 0.1 meter per second? What are the new amplitude and maximum speed of the cart? Okay. Okay, yep, I understand. That would be what would be the new amplitude? Okay, let's look at amplitude. By releasing the car from rest, you have the velocity. So now all we would have to do is plug it in. We'd have to plug it into this formula. Okay. Ready? Put this away. So we have this formula, v velocity equals k over m a x squared minus x squared. So now, in order to find the amplitude, we can isolate for this one using this formula. And the maximum speed. Are these different? Is this different from maximum initial velocity? So first, we're gonna have to... Well, we can calculate maximum speed from here. V max equals WA, which is k over ma, and this is amplitude. So, fuck. Brick. Well, first let's find the amplitude, okay? So I think it's like, if you have the velocity, the initial velocity, it might be okay to use this one. Negative 0.1 equals k over m, which is 20 over 0.5. A squared, which is 0.03. No, actually it's a squared minus 0.03 squared, like this. So now I'm gonna have to like a bunch of like bullcrap. Negative 1 divided by 20 over 5. So divided by 20 divided by 0.5, which is 40. I shouldn't have had to like, you know, do that. Squared. Now I have to square it. Squared. 0.0000625 equals, like, I'm trying to get rid of this, and then you add 0.03 squared equals a squared, so now you have to root it again. So now it's 0.03 squared plus 0.000000625 equals, and now you root it. And now the new amplitude is equals 0.0301, like centimeters or meters. So here it is, and if you multiply that by 100, it's like 3 centimeters again. So I'm pretty sure there I did something wrong. Brake's gonna start in 1 second. The maximum speed of the car is just k over m, which is k over m, it's 20 over 0.5. And then you have to root it, and then you have to multiply it by amplitude, which is times 0.0301, which is like velocity equals 0.1903 meters per second. And okay, let's quickly go look. Sorry, here are my 2 answers. Break's gonna end. Oh, I got a speed run. 0.0339, then 0.214. Okay, so I got him wrong. Okay, but anyway, just like there, and also the videos. Well, the video's not over. Okay, and let me look at what I did wrong. Oh crap. Okay, I got it wrong. Yeah, I had to evaluate the total energy of the system, and then you can solve for amplitude. Gosh darn it. Okay. Here we go. Okay. Okay. Well, what I did wrong was this formula right here, and honestly, like, video's over. You know what? I'm going to go take a break. I'm hungry. And then will I come back? I don't know. I don't know what I want to eat French fries, and there are French fries cooking right now. Then I'm going to finish this chapter today. How about that? That's my goal. And then I'm gonna come back and I have to do 16, 17, and 18 as well. But obviously I'm not gonna do everything in one day. Also, I'm kind of like, where are the questions? Where are the like the quiz questions? But anyway, learning this is probably okay. This is probably okay as long as I'm learning stuff. And if I come back and it's harder, then that's just how it is. But it's supposed to say 2 hours. And I don't know how to like I don't know how to edit a video to like add 2 clips together, which like sucks. Probably. Okay. That was pretty productive.